We have taken the IR hoist on the pallet for erection purpose, and it is taken in the pallet and nearer to the beam on which we want to erect the hoist. And for that purpose, we have taken out the trolley plates from one side. Now we want to see that the flange width of the hoist. We have to check the flange width of the beam on which the hoist to be mounted. First we will check, then again we will see that what is the beam size of our trolley originally. According when we are measuring the beam of the hoist, we have to see that it is the distance between two wheels, and for that we have to adjust the washer which are on the load axle from outside and inside of the hoist, and then accordingly we are adjusting the washer which are outside that washer to be put inside on the load axle equally on both sides, and then we will lift the hoist and mount it on the beam. After adjusting the hoist on the load axle equally on the both sides, then we'll feed the plates which we have taken out. We'll feed that, and again we will feed the number of equal number of washers on the outside of the trolley, and that is to be tightened fully, and we'll see that the flange width, the distance on the flange width, check that there should be 3 to 5 millimeter clearance for running the trolley smoothly on the beam. after mounting the trolley plates, we are fitting trolley connection flats on the trolley plates, which are to be firmly fitted on the trolley plates. In case of the bogie operation, will not fit this trolley connection flat when there is the straight path. In that case only we are fitting these trolley connection flats. For the bogie operation, the trolley plates, they are to be trolley to be running on the curved path. So the trolley connection flats are not required. After fitting trolley connection flat, we'll fit this counterweight. The counterweight is required for balancing the trolley. That counterweight to be fitted on the opposite side of the trolley motor. And for fitting this counterweight, we have to fit the hex bolt, and that 4 hex bolts are to be tightened firmly, and for more safety we will put the wire for locking these bolts, so it will not lose in the process or in the case of vibration. So the counterweight fitting to be done very properly, so that there should not be any accident due to loosening of the counterweight. We have adjusted our trolley such that there should be the running clearance between the trolley wheel flange and the beam. It should be of at least 3 to 5 millimeter running clearance, so that our trolley will move freely.
hoist from the wooden case. Then we have taken out the instruction manual of the hoist. Then we have taken this hoist on the lift. Then we have adjusted this flange width of the hoist, and we have mounted the hoist on the trolley. And next, this, as we know, this is the IR model, and this is the compact design, and this design is so compact and lightweight that this motor and the hoist is parallel to each other, so that it becomes so compact. And in this model, this IR model, we have various capacities like 1 ton capacity, 2 ton capacity, 4 ton capacity, 5 ton capacity, then 10 ton capacity, 15 ton capacity, and 20 ton capacity. These are the capacities, and our standard lift is of 6-meter lift. Then we have these various features in this, because this IR model is we have the protection for this particular hoist, and the hoist protections are this: we have the limit switch, that is the top limit switch, then the bottom limit switch, and then for the trolleys we have the limit switches, that is city limit switch, that is called the cross travel limit switches. The cross travel limit switch that prevent the collision of the trolley with the side wheels, and this is the feature of this IR hoist. And this, I will tell you, this is we have this world class model under the compact model, and this is European standard FEM standard hoist model, and the gearbox capacity is 2000 hours. This is the lifetime of the gearbox. 2000, more than 2000 hours is the lifetime life cycle of this particular type of gearbox. Then we have the compact. This is the as I have said, this is the modular design. This is very easy to maintain. This is the gearbox. We have the drum here. We have the motor there. Because of this, drum is directly mounted on the gearbox, and also the motor is also mounted on the gearbox drive, so that it becomes so compact, and the approach of the side is there is no wastage of the space from the end side. So this can be the motor is this is a compact, low maintenance hoist, low noise, multiple and two immersed gearbox. These are the features of this, and these gears are precision machines, hardened and grounded gears are there. Then this lightweight, robust, and this is aluminum die-cast gearbox. So it is enabled to have the lightweight of the hoist. Then we have the efficient motor. The motor is of the standard of I-55 standard, and we can for this hoist we can have VF drive for the speed that is low speed and high speed, and we have to just adjust your speed with the VF drive, and that is from 10% to 100%. The minimum can be 10% speed, and the maximum can be the 100% speed, and the speed of the hoist is normally 6 meters per minute to 8 meters per minute, and the dual speed that will be depend on the customer's requirement, that can be adjusted on the VF drive. See the operational part of the hoist. The operational part will see the hoisting of the hoist, lowering of the hoist, and how the limit switch operated. That will such a. Also, we'll see the crash travel of the hoist. Now, please do the lowering of the hoist. This is the lowering of the hoist up. This is the hoisting of the hoist. Now, this he's pressing the button. Still, this hoist is stopped because of these top limit switch get operated, and we have to say that bottom limit switch as per your requirement of the lift. The hoist is of 6 meter lift, but if your height of lift is of say 4 meter lift, in that case you have to set the lower limit switch to that level, and that limit switch is operated. Now this again we will see the lowering part. Hoisting. Now we see the cross travel of the hoist. For the cross travel also, we have city limit switches. Now we cannot see the other side of that, but city limit switches are there for the hoist on the both the trolleys, and we have the stopper over there. That stopper has to be fitted by the party on their girder or any crane that is in the proper position, so that your city limit switch get operated when it is reaching to the end of the hoist. Now we'll see how the cross travel is done. This is the cross travel again.